Okay, how do we use radians? Well, first of all, what is a radian? A radian is a unit of an angle. It's equal to an angle at the center of a circle whose arc is equal in length and radius. So, at first it's like, what does that mean, right? That's why I put this GIF on this page that I got from Wikipedia. I'm just going to give it some credit. All right. Okay, so we have some length r, the radius of our circle. Now if we take this radius, so it's equal to the angle at the center of the circle whose arc is equal in length to the radius. So we took that radius, we made it the arc as well. Then this angle is a radian. 2 radians, 3 radians, just past 3 is pi, 3.14, and so on. So halfway around the circle is pi radians. Complete the circle, 2 pi radians around. So if we break that into quadrants, we have between 0 and pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. Okay, let's talk about converting from degrees to radians or radians back to degrees. If I want to convert from degrees to radians, I take the degrees and I multiply them by pi over 180. But since we leave these things in terms of pi, you pretty much just divide it by 180 and put a pi in the numerator. All right, I'll show you what I mean. So let's do an example where we go from 135 degrees. And I'm going to convert that to radians. Well, I take my 135 and I multiply it by pi over 180. So really all I'm doing is doing 135 divided by 180, and that's 3 over 4. And then we still add the pi in the numerator. So 135 degrees is 3 pi over 4 radians. Okay, if we're converting from radians to degrees, we multiply 180 and the pi's will cancel out. So if I wanted to do 7 pi over 4, and I want to know what that is in degrees, I say 7 pi over 4 times 180 over pi. Well, the pi's are going to cancel. So it's really just 7/4 times 180. And this will be 315 degrees. So, to sum it back up, if degrees to radians, you're pretty much just dividing by 180, and radians to degrees, you're multiplying by 180. And you're either introducing a pi or the pi's are going away. Okay, we're going to try and sketch 11 pi over 6 in standard position. Now, there's a few ways that we can go about this. We can just look at 11 pi over 6 and think, okay, 11 pi over 6. The next easiest number to divide by 6 is 12. 12 over 6 is 2, right? So 11 pi over 6 is almost 2 pi. So I have a feeling it's going to be in this quadrant. The other way I can go about it is I can just look at each of these, the 0 and 2 pi, pi over 2 pi, 3 pi over 2, and I can make them all have, I can rewrite them all as a divided by 6. So instead of 2 pi, to get a common denominator, that'd be 12 pi over 6. Right? Because 12 over 6 is 2, so these are the same. If I needed something over 6 that gives me a half, well, then that'd be 3 pi over 6. And to give me just 1 whole pi, that'd be 6 pi over 6. For 1 1/2, it'd be 9 pi over 6. And that helps me a little bit, because now I can more clearly see that 11 pi over 6 is going to be between 9 pi over 6 and 12 pi over 6. So starting from the positive x-axis and going around, once I sketch the angle in standard position, this would be 11 pi over 6. All right, so now we're going to sketch the angle and find the reference angle for 7 pi over 6. So this is kind of nice since we've already changed all of our units to be divided by 6. It's easier for me to see that 7 pi over 6 will be just past 6 pi over 6. So in standard position, I'm right over here at 7 pi over 6. Now, the reference angle is that angle that gets us, it's the acute angle that goes back to the x-axis. So I'm trying to find this angle right here. To find this reference angle, I only need this much, so I have all of this pi left over. That's funny. So I have 7 pi over 6. I'm taking away pi. Now earlier we saw that pi, I could write this like this. 7 pi over 6 minus 6 pi over 6. Because 6 pi over 6 is the same thing as just pi. So taking away 6 pi over 6 from 7 pi over 6, I have pi over 6. This is my reference angle. The other way to approach that is just to say, okay, I went 7 pi over 6. This was 6 pi over 6. How much did it take me to get from 6 pi over 6 to 7 pi over 6? Just 1 pi over 6. Okay, let's find a positive and a negative coterminal angle for negative 7 pi over 4. And let's also graph it, because we need to practice graphing. So it's a negative, so I'm going to be going around the other way. So with radians, whenever I'm going around, instead of this being pi over 2, I have to count. Okay, I went negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So negative 7 pi over 4, that's really close to negative 2. And just to, let's just keep going around just like I was saying. So I've gone negative pi over 2, which is negative 2 pi over 4. So I keep going. This is negative pi, which is the same thing as negative 4 pi over 4. So, not to negative 7 yet. Keep going. This is negative 3 pi over 2 around. So, that's negative 6 pi over 4. And I can stop right here at negative 7 pi over 4. Because if I go all the way around to 2 pi, negative 2 pi, well, that's negative 8 pi over 4. Alright, so for coterminal angles, we found them by just adding and subtracting 360 degrees. So for radians, I can find my coterminal angles adding and subtracting 2 pi. So for my coterminals, I could do negative 7 pi over 4 plus 2 pi and negative 7 pi over 4 minus 2 pi. Well, to add these, I need a common denominator. So negative 7 pi over 4 plus 8 pi over 4. So one of my coterminal angles is pi over 4. And then we have negative 7 pi over 4 minus 8 pi over 4. So I have a negative coterminal angle of negative 15 pi over 4. Okay, complementary and supplementary angles. Find the complement and supplement of 2 pi over 5. Well, in degrees for complement, it's 90 minus the angle. So instead here, we're going to do pi over 2 minus our angle. So for us, we have pi over 2 minus 2 pi over 5. We're going to make a common denominator of 10. That'd be 5 pi over 10 minus 4 pi over 10. So the complement of 2 pi over 5 is pi over 10. The supplement is found by just taking pi minus the angle. So we have pi minus 2 pi over 5. So 5 pi over 5 minus 2 pi over 5. The supplement of 2 pi over 5 is 3 pi over 5. And again, if you wanted to, you could convert 2 pi over 5 to degrees and do 90 minus that degree, 180 minus the degree, and convert it back to radians. And get the same answer. We're going to sketch and find the reference angle for negative 5 pi over 3. So, going around, it's a negative angle, so I'm traveling this way. Now, the very first thing that I would hit is I've gone a distance of negative half of pi, right? Well, what's that over 3? What's half of 3? So I've gone negative 1.5 pi's over 3. And I keep going, and now I've gone negative 3 pi's over 3, right? Because I've gone negative 1 pi. Then to go negative 1.5 pi, well, 1.5 times 3 is 4.5, so I've gone negative 4.5 pi over 3. Now I'm trying to get to negative 5 pi over 3. If I keep going, I'll get to negative 6 pi over 3. Because that would be a distance of negative 2 pi. So I know that my angle is about right here. So the angle that I was trying to sketch was negative 5 pi over 3. Now I need to find my reference angle, which is the acute angle that gets us back to the x-axis. Well, if I've gone negative 5 pi over 3 and I'm just trying to get back to the x-axis, which is negative 6 pi over 3, how much more do I need to go to get from 5 to 6? Just pi over 3. So to find positive and negative coterminal angles for 5 pi over 4, I'm just going to add and subtract 2 pi from 5 pi over 4. So I've got 5 pi over 4 plus 2 pi. Or I could write that as 5 pi over 4 plus 8 pi over 4. So I have one coterminal, a positive coterminal of 13 pi over 4. Or I could subtract 2 pi, so 5 pi over 4. We've already done the conversion, so minus 8 pi over 4. This has a negative coterminal of negative 3 pi over 4. And now I've found a positive and a negative coterminal angle for 5 pi over 4. All right, and that's as far as we're going to go with radians today.